We can refer the data sheet. These three terminals you can see. This is how it looks like. And then take it out and based on the temperature, it will decay, and based on temperature, the output voltage of the sensor will vary. Okay, so let me show you a demo, then you can understand. So I'll take LM35. So this is the LM35 temperature sensor. So you can see it has three terminals, 1, 2, 3. What is the use of first terminal? Just check the data sheet. Tell me. Pin number 1 is for VS. VS means supply voltage. That means the sensor has to work, right? So for that we have to give some supply voltage. The range of number volt, so this is the operating voltage, supply voltage from 4 volts. So it was pretty easy. Clear? It says voice is breaking. Is that clear? Right. So I think network is good now. Okay, sometimes it's breaking. Okay. Fine. So here the pin number 1 is supply. So I'm giving supply voltage some 10 volts because we can give from 4 to 30. I'll give 10. Okay. And what is pin number 3? Is yes. I complete it and then I'll also repeat one second, sir. Don't worry. Okay. Yeah, check the data sheet. What is for pin 3? Pin number 3. Pin number 3 is for output. Pin number 2 is for ground. Okay. Pin number 2 is ground. Pin number output. So let me try to. So is ground, not 2 is ground. This is LM35 DT. Okay. So let me. Okay. I think this model is not LM35 DT. For this particular sensor, I think pin number 3 is what ground. Okay. Because they are given V out to pin number 2. Okay. So I'll connect the ground here to pin number 3. Okay. So pin number 3 is ground for this particular IC because they have marked a V out at pin number 2. Okay. So pin number 2 will get the output voltage. Okay. So let me see the output voltage. Let me connect a meter. So I'll connect one voltmeter, something like that. Okay. Say volt probe connected. Okay. So now what I'll do, this 27.0 is the temperature. So I'm just showing that if the temperature is some value, what will be the output voltage? Okay. So let's say if the temperature is 27, you can see the output voltage is 0.27 volts. So when you measure pin number 2, and if the pin number 2 happens to be 0.27 volt, now you can understand right now the temperature is 27 degrees Celsius. Now let me try to reduce the temperature. Okay. I'll reduce the temperature to 0 degrees Celsius. I'm not going negative because negative will not come normally. So I just go only with the positive values. So let's say if the input is 0, I'm getting 0 volt. Okay. I mean the temperature is 0, output is 0. So I'll measure the output, and if the output voltage is 0, then I can understand the temperature is 0. Let's say let me put 10 degrees Celsius. If 10 degrees Celsius, I'm getting output of 0.1 volt. So if 0.1 volt, I'll get, it means it is 10 degrees Celsius. 0.2 volt means 20 degrees Celsius. Let's keep 20 volt. So 20 degrees Celsius. Now you can see the output voltage is 0.2 volt. Now for 30 degrees Celsius, the output voltage will be 0.3 volt. So now you can see it is 0.3 volt. If the temperature, let's say 60 degrees Celsius, let me put 60, then it is 0.6. If it is 60 degrees Celsius, then you can see it is 0.6 volt. Okay. If the temperature is 100 degrees Celsius, let's say, and the output voltage is 1 volt. Okay. Maximum we can go up to 150 degrees Celsius. So I'll keep the maximum. At 150 degrees Celsius, we can go, the output voltage is 1.5 volt. So that means the physical quantity, which is temperature, I cannot measure it directly. So I use a sensor. The sensor will give you equivalent output voltage. My microcontroller can read that voltage, and then I can estimate what will be the current temperature on the sensor. Okay. So this is what we do with this IC. Okay. So let me show you a program. I've written a program to demonstrate you. So let me try to show you that also. So here, if you look at, here I have this temperature sensor. Okay, so I've given this temperature sensor. The temperature sensor output is connected to sender pin. The pin number 2 is connected to the microcontroller. Okay, so it is going to the microcontroller pin. Okay, microcontroller pin. So this is how we do that in BMS also. Inside BMS also you can see either thermistors or ICs, temperature ICs. If the temperature IC is used, then you will connect like this. And I'll also show my code. This is the code, and I would like to explain here. So these two lines. So you can see in this line I'm measuring the voltage. I can measure only the voltage, but the temperature value I can show by estimating it, by calculating it. Okay, is it clear? So if you look at right now, if suppose the voltage is 1.5 volt. 1.5 volt means the ADC number or the microcontroller ADC value will be 1023. 1023 means 1.5 volt. So if this is 1023, then if you look at my temperature will be 150 degrees Celsius. Okay. If suppose the voltage I measured is half, let's say half of this, instead of 1023, I'll write it as 512, which is half of that. Okay, half of that. Then the temperature will be 75 degrees Celsius. Okay, so you can see now 75. The temperature has changed to 75. So what we are trying to do, we are trying to measure the output voltage from the sensor. Okay, and from the output voltage, we are estimating the temperature. Okay, we are not measuring the temperature. We cannot measure temperature directly. We'll get the voltage and thereby we recalculate or calibrate or manipulate the temperature value. Okay, don't get confused with this 512 and 1023. This is the number or an ADC, analog to digital conversion number, which is used inside the microcontroller. Okay, don't get confused. Okay. So is it clear? Is it clear, everyone? Do you want me to explain again if something you have missed? Is it clear? Or do you want me to explain again? Okay, okay. So in all electronics, okay, temperature we cannot measure it directly. Either use a thermistor and get the divided voltage and then manipulate what will be the actual temperature, or you use an IC, temperature IC, get the output voltage and then manipulate what will be the temperature. So the output voltage versus temperature data that you can get from the data sheet itself. That means if this is the output voltage, what will be the temperature? So that correlation, that mapping will be given in the data sheet itself. So you can use that data and write your program and get the temperature data on the screen. Okay. This is just a demo just to physically have an observation on how things are done. Okay. So is it clear? Fine. So now I have to do one more sensing, which is current sensing. So now we'll understand how in a circuit current is sensed. Okay. Let us try to draw a small circuit for you, and then you tell me how can we measure current. Okay, I'll give you only 10 rupees. Okay, the development cost for measuring current is 10 rupee max. Okay, 10 rupee or let's say 20 rupee also, but I cannot spend more than that. Okay, fine. So let's say I have a charger. Okay, and the charger is giving 5 amp. 5 ampere is coming from the charger. Okay, we don't know it is 5 amp, but I'm telling right now it is 5 amp. And this 5 amp current is flowing. Okay, is flowing through the battery. Okay, through the battery. Okay, so this is your battery. It can be any configuration, 4s2p or 8s2p, whatever it is, anything. And we connect the battery negative to the charger negative. So this is how the circuit gets closed. Okay. Now assume that some current is flowing. How do I find what amount of current is flowing in this circuit? I can spend only 10 rupee or 20 rupee. That is, so I need a concept under that budget. Some current is flowing from the charger, but I wanted to measure what is the amount of current flows through the charger or flows through the battery. This is charger plus, this is charger minus, and this is battery plus, this is battery minus. Okay. Okay, so normally what we do, we use something called shunt resistors. Shunt resistors to measure current. Now, what is this shunt resistors? They are a resistor which high sensitivity, and their size is also high. I'll tell you why the size has to be high and what. And these resistors are very low value of resistors. Low value. So low value, big size, very huge size. Okay. And these resistors looks like a normal resistor. Okay, I'll show you the resistor also. So right now I'll draw like this. So I'll put a resistor something like this. Okay. So this is our ground point, that the final end point, the current end terminates to charger minus, correct? Because the current starts from charger plus, and after flowing, the current reaches to the charger minus, right? So the charger minus is my ground. Now, how the current is sensed is we measure this voltage. Okay, this voltage we measure, and we know there is a resistor, so resistor will have obviously. So, for example, 5 resistor I put is, as I said, it should be very low value of resistor. I'll tell you why low value. The low value means it will be 0.1 ohms typically, or 0.001. Okay. The voltage drop. If 5 amp current is flowing, if 5 amp current is flowing, what is the voltage drop? What is the voltage drop? V equal to IR, E equal to IR. So I, the current flowing is 5 ampere. The resistor is 0.1 ohms. And resistor value is 0.1, so it is 0.5 volt. So that means if I sense this resistor right now, sorry, this is plus, this is minus, this is plus, this is minus. Because the current will flow like this, correct? Current flow like this. So when 5 amp is flowing, the voltage drop across the resistor 0.1 is 0.5 volt. 0.5 volt. If suppose 1 amp is flowing, assume, instead of this 5 amp, 1 amp is flowing, then this voltage will be point. If it is 2 ampere, 0.2 volt. If it is 3 ampere, 0.3 volt. If this is 4 ampere, 0.4 volt. So what we are doing, we are measuring the voltage drop across that resistor, and thereby we get what amount of current flows, because we use the formula current equal to I equal to V by R. V by R. V equal to IR, so I equal to V by R. So I equal to, in this case, what is the current? V by R. V means how much voltage? It is 0.5 volt. And divided by what is the resistance value? It is 0.1. So 0.5 divided by 0.1 is 5 ampere. So this is how we understand the current flowing through the circuit. So very simple way that we use a very low value of resistors, okay, very low value of resistors in the current sensing path, the current flowing path, and we measure the voltage drop across that resistor. By measuring the voltage drop across the resistors, so we will get voltage drop B, and we know what we have connected. Thereby we can use the, and we can find what is the current actually flowing through the circuit. Okay, so this is how the current sense is done in a very cheap way. Okay, very low cost way. Now the question is that why low value? Because if I put very high value, let's say, assume that if I put 10 ohms, assume instead of 0 ohms, if I put 10 ohms, then for this 1 ampere of current, okay, 1 ampere of current, what will be the voltage drop? Assume the charger is a 29 point, not 29.4 is, we have a 15 volt charger, right? 15 volt. So for 1 ampere of current, what will be the drop if I put 10 ohms? What will be the drop? V equal to I into R. So I is 1 ampere, R is 10 ohms. So the voltage drop for this resistor is 10 volt. So that 15 volt, okay. So that means if we drop the voltage more, the battery will not get sufficient voltage to charge. Okay. So that is the reason. For example, if I put here, instead of 10 ohms, assume if I put 0.1 ohms, okay, 0.1 ohms and 5 volt. That means out of 15 volt, only 0.5 volt drop will be across the resistor. Remaining 14.5 volt will occur across the battery. Okay. So if suppose 14.5 volt is also not sufficient for you, let's say you say that, sir, I want to charge up to 14.8. Then what should I do? Instead of going for 0.1 ohm resistor, I should go 0.01 ohm resistor. So if I go for 0.01 ohm resistor, if 5 ampere current is flowing, I will lose only 0.05 volt. Remaining 14.95 volt will go to the battery. Okay, so this is how you have to think when you want to choose a current sensing resistor for the application. So that's the reason we normally choose very low value of resistor. Even you can see in this case, 0.1 ohm resistor is also very difficult, because if I put 0.1 ohm, 0.5 volt will be dropped across the resistor, and the battery will get charged only up to 14 point. In our 4S configuration, we can charge the battery 3.65 into 4, right? And 3.65 into 4 happens to be 14.8 volt. So that means I wanted the battery to charge up to 14.8. So that means I'm very careful. I should be very careful in dropping this resistor, or in dropping the voltage across. And that's the reason we go even lower value of resistor. So if I go 0.01 ohms, I'll be dropping only 0.05 volt. If I drop 0.05 volt, out of 15, 0.05 volt will go across the resistor. Remaining you'll get 14.95. So that is okay, fine. Because you wanted 14.8 only. So your input is 14.95. That is great. No issues. Okay. Where is BMS? Yeah, we'll come to that. Please wait. Please wait. I told you, no, we are trying to understand the parameters first. Okay. This is one part, one parameter inside BMS, sir. Okay. So we wanted to design BMS. After we'll be trying to select BMS, we'll try to draw the BMS interface. But before that, we need to know, right, how the temperature is sensed, how the current is sensed, what circuit it is using inside, what is the methodology they use. Maybe the circuit will be different. The methodology has to be same. Okay, so that's the reason I am trying to explain. Otherwise, you will understand. Okay, BMS we have to wear like this. That's it. But you don't never understand how things are being done internally. Okay, so that's I give more importance to make you to understand how the process of sensing happens. Okay, after break we'll definitely do. We'll go with the BMS section and how to interface. All these steps we can do it. No issues at all. Okay, so hope you understood how careful we have to be when we search or when we select a current sensing resistor for any circuit. Okay? Because in the market you may get 1 ohm resistor also. You may get 0.5 ohm current sensing resistor also, 0.1 ohm also, 0.001 ohm also. Okay, but you choose an appropriate resistor value, current sensing resistor value, making sure that the sensing resistor is just for sensing. You should not drop the supply voltage and affect the battery. Okay, so that is the one take care you have to do while you do current sense. Let me show you different current sensor values or resistors available in the market. We go to some website, commercial current sense resistors. So you can see here 20 milliohm value, 20 milliohm, that means 0.02 ohms. Okay, so these are SMT packages. Okay, SMT packages. Through hole you have like this. This is the through hole resistors. You can see 0.0 ohm, 5 watts, 0.1 ohm, 0.00 ohm. Right? So they are very, very low value of resistors. Okay, and why it should be bigger resistor? Why it is bigger resistor? Because you know very well the sizes of the resistor we choose by knowing the power dissipation, where power dissipation is I square into R. Assume in this case I'm using 0.1 ohm resistor. Assume 0.1 ohm resistor to do 5 amp sensing, up to 5 amp sensing. Then my potential, then power dissipation is 5 square into 0.1, correct? So 5 square is 25. 25 into 0.1 is going to be 2.5 watts. That means the resistor will have a dissipation up to 2.5 watts. So I cannot go with 1 by 8 watt resistor. I cannot go with 1 by 4. I can't go with 1 by 2. I have to choose a bigger size resistor because the current flowing through the resistor is very huge because it's sensing current. Thereby the dissipation is huge. So you have to choose a bigger size resistor of low value. Okay, so that is what it happens in current sensing. Okay. Any doubts? This we have seen sensing and we have seen current sensing. So any doubt up to this? Anyone? So if there is no doubt, after the break, we'll break now. And after the break, we'll see. I will try to select BMS for different configuration. So we have discussed 4S2P, 8S2P, and 15S4P. So we'll try to select BMS for our application. And then we'll try to connect or interface your BMS with the battery pack of 3 different configuration. Okay. So this we'll do after the break. Fine. So we'll break for 15 minutes and we'll be back by 8:55. Please draw 8S2P configuration. 8S2P. Please draw 8S2P configuration. Please complete and then type done in the chat box. So this is our question. Design 8s2P battery pack and interface BMS. Okay. Now, given specification is LFP 3.2 volt 6Ah 3C cell. So we are going to use LFP 3.2 volt 6Ah and 3C cell for making the battery pack. And maximum charging current rating is 0.5 C for the pack. And maximum discharging current rating is 3 C for the pack. So this is the spec which is given. So what you have to do, first you have to design 8s2P battery pack and then choose BMS. Okay, so first make 8s2P battery pack and then select BMS. Okay, so the question A is design 8s2P battery pack. Then B, select appropriate BMS. Make, you can go for DALI BMS. Then interface means wire harnessing or wiring. Okay, connection. Okay, interface BMS with the battery pack. Okay. So we have to solve all the three questions. So I wanted you to do all the three, and if you have any doubts, you can ask me. Or first do A and B, and tell me what BMS you have selected from DALI, and then I will teach you the connection diagram, how to connect BMS with the battery pack. So please complete it. So once completed A part, 8s2P configuration. If you have drawn 8s2P battery pack configuration, please type done in the chat box. 8s2P. Have you completed? Let's complete the 8s2P battery pack. Okay, others, please respond if you have completed drawing 8s2P battery pack. No problem, the value is fine, but have you drawn it? Because we need to do the BMS connection with the battery pack. So if you draw the 8s2P configuration very neatly, then you'll be able to interface, do the wiring connection for battery pack and BMS. So draw it very legibly, clear. Okay, I'll ask someone to share your screen also. Deepanshu, have you completed 8s2P battery pack? Don't do C part. I would like you to do A and B. First complete A and then select the BMS. Okay, select the BMS means what? What do you mean by selection of BMS? If you don't know that, then I'll help you how to select BMS, but I wanted everyone to complete the A part, design 8s2P configuration part. You have to complete it. Rituraj, Harshu, have you completed? Okay.